All right, welcome to Planetary Health First, Mars Next. I am Michael Mann. I'm the host, and today we have a cool, amazing guest, another Michael. What can he do wrong with Michaels? Two Michaels in the room. Well, I don't know. We'll find out. Michael Fossel. Would you quickly introduce yourself? I know you've done this before, but you'd be much better than me at it. Just share with the audience a little bit about yourself, please.
Well, I sort of attempted to introduce myself by talking about things that have nothing to do with your CV. It's like I'm the only one you'll ever meet who has wrestled with, bitten, and been bitten by and kissed a gorilla. That kind of thing adds to the fun in life. I just built a Japanese tea house. But I guess if we're going to be more serious, MD and PhD from Stanford, used to teach experimental methods there, neurobiology there, got fascinated by aging, have written 6 books. The latest one just came out a couple of weeks ago. About 100 articles, gave the first talk at the NIH ever on aging, the first articles in the medical literature on aging reversal. And now working in biotech, trying to see if we can take this to human trials.
You know, this is great. I love the Japanese tea house. Are you in somewhat of a Japanese tea house? Your style is that outside? Where is that?
That's outside. That's on the other end of the property. My granddaughter asked me, how come it's so far away? And the answer is, yes, it's meant to be far away. No electricity, no water, no internet. Just beautiful little spot that I hand built over the winter.
That's really cool. My aunt and uncle had what they called as a whimsy, and it was in their place in San Rafael, and it's a sort of smaller property. They're now in a retirement community, but they called it a whimsy. And I don't know what her probably was just getaway, sort of the same thing. She had her little tea house. So is it imagination, a place of imagination, meditation, reflection, and all the above?
All the above. A friend of mine said I shouldn't call it a Japanese tea house. I should call it an American whiskey house, because it's probably closer to its actual function. But yeah, no, it built it totally myself. It's just a lovely little place. So
cool. Well, how the heck did you get the idea to do that? What fascinated you by that? Before we were going to get into the talk today, of course. Forgive me, but
whimsy, total whimsy. The same idea as the place in California of your relatives. I just decided to do this. So I found a spot with the right feng shui out in the middle of the woods. A little path to it, built a torii gate, which I just finally put in yesterday. And then it's all glass walls with little pane separators and something I put on the glass to make it sort of wavy, and a nice overhanging roof, and 20 little kyushu azaleas and some Japanese maples and ferns, and it's just lovely. Moss everywhere. It's lovely. You'll have to come out sometime.
I love that. I do drink tea. I'm drinking tea right now, yerba mate, with a mixture of green tea, ghee, and coconut. And hopefully, is this going to help with any aging, brain health? And I don't know.
Well, the question is does it help with aging, or does it just make you feel better about it? Sometimes people say to me, if I get the right diet, can I live? And the truth is, if I knew that I could double your lifespan by making you live in the basement in the dark and eat nothing but cardboard, would you do it? The answer is no. That's not life at all. Mm-hmm. So here's to you, tea, whether it helps or not. I hope you enjoy it.
So what do you want to unravel today? Where do you want to go? This is our time together.
Okay, so we'll slip into a slightly more serious vein. One of the things that always has worried me about aging and people thinking about aging is that they start with assumptions that they never examine. And we've done this historically forever. The assumption in the Middle Ages was that plague was caused by evil spirits and bad air and all sorts of, original sin. And nobody ever thought to, reasonably enough, ask about invisible microbes. Can't talk, too much coffee. But they never thought to ask about what really caused it. Another example might be if we go back not that long ago in the centuries, I know that the earth goes around the sun because I see it come up in the east, I see it go down the west, and I'm not moving. Well, the assumption is I'm not moving is poorly based. And the earth does go around the sun, and we rotate. But I think the same is true of aging. We tend to assume it's just wear and tear. And I used to run into this back at Stanford in graduate school. What causes aging and age-related diseases? And the answer is you rust, things fall apart, entropy, wear and tear. And I found that a very blasé sort of approach. And usually when people are that blasé about it, they already know what's going on. it means they haven't even thought about it. And I began to wonder what's really going on with aging. And what I discovered right away was it was sort of an elephant in the blind man problem. You found that everybody knew pieces of the elephant, but nobody thought there was a real elephant. So you found all of these little pieces that had to do with aging and age-related diseases, but it was hard to put them together. What did mitochondrial aging have to do with immune system aging, have to do with progeria, have to do with glycation? How do you fit these things all together? And so I began to think of it as more of a process or a systems issue, a dynamic, complicated process. And most people don't. They just think it's wear and tear. And it reminds me of that old quote about whether you think something can be done or can't be done, you're right. And it's attributed to Henry Ford, but I don't care. It's still true. If you think you can't reverse aging, then you can't. But we tend to assume that aging just happens, and that's a mistake. Aging is not just entropy, it's entropy that occurs in the face of maintenance. And we know that maintenance has kept you and I, every cell in your body is essentially 3 billion years old. And likewise, the mitochondria approaching 2 billion years old. So you can't very well say that aging is just entropy without explaining why entropy occurs in some cases, not in others. And in certain animals, it occurs faster than in other animals. So it's clearly more complicated than it just happens. But that's what I see happening. In aging, people tend to see it just happens. And so what they try to do is ameliorate it. Let's give you a vitamin, let's have you exercise, all of which are good ideas, but they don't speak to the heart of the problem. And part of that problem is, again, we tend to not see the whole elephant. We see pieces of it, and we make assumptions that are simply not warranted.
Yeah, I love this. So I'm hearing you're getting at the root cause, potentially, like the underlying cause, and we just don't do that in healthcare. And it seems like I love how you use the analogy with, I guess you were talking just how certain things in the back were of time with evil spirits causing disease. We can't use that anymore, but we're almost using myths or not going any deeper and not much further ahead. So how do we move it further? I mean, I know you're doing it, working your whole life at it. Sounds like, I know you're a scientist, but I almost see you as like almost so out, like I don't want to say like an astrophysicist, but if you, you're really getting into something deep, and I imagine it's taken a long time. Is there still a lot of lack of belief in what you're doing? Like the awareness part, debunking it, or where are you in that? And that was a long mouthful.
Well, I sort of, in one respect, it doesn't matter whether people think something's foolish or not. The question is, does it work? As I've sometimes said, if you can prove to me that blue pentagonal crystals cure malignant melanoma, I may think that's trash, but if that's what the data shows, I'm going to have to reassess the way I look at the world. And I think that's here true too. The question isn't what do I think, or what do I post on social media, or what am I an influencer for, or do I have high SEO, or do I give TED Talks? The question is, does the damn thing work? Mm-hmm. When I gave this talk at the NIH back 27 years ago, 28 years ago, I said, the title of the talk was Reversing Human Aging. And I said, anyone who leaves this talk in an hour and thinks you can reverse human aging is naive. But anyone who leaves this talk in an hour and thinks you can't reverse human aging is equally naive. The question is, where's the data? And there wasn't much data, but let me tell you what there is and where we're going from here. And I think that's true too. Now, if I'm trying to get funding, I have to convince people of it. But I think beyond that, the question still is, what do the human trials show? What does the data show? Is it effective? I've sometimes said that I don't care what causes aging. I'm not sure that that word cause is complex enough or is realistic enough. It's like saying, what's the purpose of life? It depends what you mean by that. I'm not sure, what's the answer to life? 42. I don't know that you can say what.
Which is a Douglas Adams reference, yes, correct? Right. Okay, awesome. Awesome. All right.
But I'm not sure that we should be talking about what causes aging, except as we're trying to understand the process. It's like saying what causes poverty, or what causes the universe, or what causes, it depends how far back you want to go. And from my perspective, and when you're looking at what causes aging, you could ask it teleologically or evolutionarily, is there a purpose to it? Does it help species survive? You could ask that. You could talk about the concatenation of problems that occur. For example, if I smoke, do I increase damage to my lung? Does that increase lung aging? Does that cause age-related diseases like COPD? That's one question. From my perspective, it's not a theoretical or a philosophical question. It's a practical question. My question isn't so much what causes aging or age-related diseases as what's the optimal point of intervention clinically and financially. Can I find a place to intervene that is cost-effective and helps people? Example, say I've got heart disease, severe heart disease. I could lower my blood pressure. I could quit smoking. I could change my diet. I could put myself on a statin. I could get stents. I could have a coronary artery bypass graft. I could get a heart transplant. Well, what are the most effective things for that? I'm not in favor of heart transplants. They're expensive. They're uncomfortable. But on the other hand, maybe it beats dying. What about stents? What about statins? What about changing my diet? What is the optimal point in there to intervene? So that's my issue. It's not just what causes it. It's what's the best for me as a patient, as a human being, to make my life better, to make my patients' lives better. Where can I intervene that helps?
So what are we going to see? I mean, I hear all this, but like, tell us, like, what does it look like if you were able to actualize what you're really been delving deep? I mean, since NIH 27 years ago, what would it be if your future of how you see it could be realized?
I think what we're going to do, Michael, is do something that has essentially no historical precedent. If I look back historically and I say, what's the most important thing we've done throughout all human history to improve the human lives? You might argue that it's domestication, it's agriculture, a lot of things. But speaking medically, I'd say it's microbial theory. And by that, I don't mean the latest fourth generation cephalosporin. I don't mean a lot of things like that. What I mean is the idea that invisible microbes cause disease. It allowed us to do things like wash hands when you deliver babies, which drastically lowered the rate of neonatal and maternal death. And it cost almost nothing, a bar of soap, and yet people fought it tooth and nail as being irrational. But the whole concept allowed for things like immunizations. We tend not to die of polio these days, tetanus these days, many diseases that were anathema, that really were a huge problem for us, are pretty much gone. The leading cause of death a century ago in many, many countries was gastroenteritis. Now that's relatively rare. And again, not just because of antibiotics, but because of a conceptual, not a technical revolution. It wasn't a more expensive robot surgeon. It was the idea that you could wash your hands, the idea that you can give fluids to a young child with gastroenteritis, the idea that these were caused by something that we can intervene with. So I think the most important thing we've ever done medically throughout all of human history is a conceptual revolution, understanding microbes. It drastically cut a lot of human suffering and death. I think we're about to do the same thing with regard to age-related diseases. We have never in human history intervened effectively in age-related diseases. We've done a lot of things. As I say, heart disease, I can go on for a half an hour about things we can do. Osteoarthritis, osteoporosis, a lot of things we have done, and they're not really all that effective. They don't prevent the disease. They don't stop or reverse the disease. They ameliorate it. They deal with some of the symptoms, and they may postpone death or morbidity, but they don't directly impact the disease itself, age-related diseases. We're about to do that. I think within the next few years, we're going to be able to demonstrate that we can effectively cure and prevent and reverse many age-related diseases, and that has never been done before in human history.
So are we talking about the future of people living to be 120, 150? What does this look like?
Well, let me start by saying I don't really care. What I mean is, Marcus Aurelius said this two millennia ago. He said, whether you live 50 years or 500 years, that's not the issue. The question is sort of the quality of life and what you do with your life. And I think that's true too. There was a Pew Memorial Trust study done, now good 10, 12 years ago, that basically said, if you could live an extra 30 years, would you like to do it? Most people said, no, not really. Because what they thought that meant was 30 years in the nursing home. No interest. Mm-hmm. And I don't blame them. I wouldn't either. We're not talking about that. What we're talking about is, instead of giving you an extra 30 years with Alzheimer's, reversing Alzheimer's, preventing Alzheimer's, curing Alzheimer's, which is a different issue altogether. Now, if that ends up doubling your lifespan or giving you an extra 20 years, so be it. But the point is not to extend an unhealthy or unhappy lifespan. The point is to make a happier, healthier, more vital lifespan than what you have.
So it seems like the research and what you're up to is the same stuff that could be applied to ALS, neurodegenerative disease. Is that correct? Or what else? How would you?
Right. There are a lot of diseases it doesn't apply to. If I'm a child with a Wilms tumor, I've got something that is related to me being young, a genetic abnormality, not related to aging per se. I can't deal with this. If I'm dealing with somebody who has otitis media, doesn't help. If I'm dealing with anything that has to do with actual cellular aging as we get older, then there's potential for intervention. The same could be true, for example, of a number of Friedreich's ataxia and Huntington's chorea, ALS, because a lot of those diseases ultimately may depend on changes in cell aging as we get older. There's a reason that you don't get Huntington's chorea at age 10. You get it later on. And the mechanisms are remarkably complicated, but they may play out on the stage of cellular aging. And the same may be true of ALS. ALS on the face of it is not an aging disease, but again, you don't tend to get people with ALS at age 12. You tend to get it at age 50 and 60 and 40. So to the extent that any of these diseases are related to aging of cells, then we may be able to intervene effectively. So when I think of, for example, age-related central nervous system disease, neurodegenerative diseases, we're not talking about just Alzheimer's and Parkinson's and Lewy body dementia and frontotemporal dementia and a whole host of ones. We're talking potentially about things, as you say, like ALS.
So what would you like to see happen?
Well, again, the primary question is, are we right? Does this work? I mean, as I used to say to my graduate students and my residents, it's excellent to have a logical theory that's consistent with everything you know, but data trumps every time. Does the data show that it works or not? That's the issue.
So where are we with the data right now?
Well, we've got a lot of data in human cells. The human cell data was first published in Science, actually, in 1998, showing we can essentially reverse aging in human cells in the laboratory. The first tissue data was done in the year 2000, 2001. There were a whole set of little papers in there. But again, those were done pretty much in the laboratory and in mice, using human tissues transplanted to mice. The first organism studies were done now a little more than a dozen years ago, 14 years ago, first at Harvard and then in Madrid. And what they showed is, to the extent that we're technically able to do this, to the extent we're technically able to reverse aging in cells in vivo, we can reset aging. The question is, to what extent can we do that in you? The answer is, we don't know. We're set to go ahead with the large animal studies and then move on to human studies. We just have to take our commitment to funding to actual cash in the bank and move ahead.
So it sounds like, is there an interest enough? I know I talked the other day to a venture capital, and right now the ecosystem has not been the best with those who have raised capital or invested in companies. There's not a lot of IPO. It's kind of like, it sounds like if it would be a liken to, if you're not making enough revenue, you can't, it's sort of a stopping point. And I think it sort of embodies maybe where the economy as a whole is. So is there an appetite right now I imagine there's an ecosystem that needs to happen: the funding market, the venture capital, the pharma, biotech, and I guess when I was talking to the venture capitalists, it just seems like it's a tough period right now. There's not a lot of clarity with the interest rates and the capital markets. So I'll stop there.
There are a lot of things that play a role. One is that, when our initial strategic target, for example, is Alzheimer's. And one of the standard adages in the field is that Alzheimer's is the graveyard of companies. And the reason is there have been more than 2,500 interventional trials for Alzheimer's, and by global consensus, anakinumab and lecanemab notwithstanding, they haven't been as effective as we'd like to be by a long ways, or ineffective totally. So if I'm an investor, if I'm a VC, the last thing I want to do is offhand invest in an Alzheimer's drug when I'm not convinced I'm going to do anything but throw more good money after bad. That's the background of that. Now, in the face of that have been the changes you mentioned recently, and that plays a role as well. And we're dealing with a model that most people don't understand. You know, most people, for example, when they're talking about Alzheimer's, they focus on little things, little biomarkers. In this case, beta amyloid or tau tangles or neurofilament chains. They're not looking at things in a broader perspective, and that's an uphill battle for us. Being able to get people to step outside of their conceptual comfort zone, and instead of, as it were, talking about original sin and evil spirits and bad air, talk about invisible microbes, looking at things in a broader perspective. So that's an uphill battle. Now, we've had the other thing that comes to mind. I just gave a talk a couple of months ago at Harvard Business School about aging in biotech and what not to do. And, you know, when you think about it, anytime you've got something with enormously high potential, as what we're talking about, we're in the trillions of dollars for potential. We're also talking about something with an inordinately high risk. If you make widgets and you're trying to make a few more widgets and the market is out there, and I come to you as an investor, I can see if I give you a little more money, I can make a little more money. But now and it's low risk. But now I'm talking about giving us $10, $25 million and talking about something with enormous potential, but the risk is just as high. You know, if we're wrong, you've lost a lot of money. And it's often true in investment, which is the higher the risk, the higher potential, the higher the risk. You know, sort of roughly speaking, the rule of thumb. So it gives people pause. Now, we've had a number of private investors who've come to us over the last few years, and the percentage return on our contacts is about 1% or less of people who are interested after you contact them. Of course, some people never get back in the first place. But we have some recent investors who are very interested in doing this, not just for the gain, but for the long-term public good. And that's a remarkable thing to find. There are investors out there like that. They're very careful about what they do, and they tend to be invisible, if I can call them that. The last thing they want to do is open themselves up to a lot of people pounding on their doors. So they tend to be anonymous. They tend to require that you not talk about them. And that's been the case for us as well. We have people who are interested, and they just as soon be under the radar. In fact, you know, that's been our approach as well, because as I said before, success is not a matter in this kind of issue. It's not a matter of whether you're an influencer, how many contacts you've got on LinkedIn, what your SEO scores are, you know, whether you give TED Talks. The question is, does the darn thing work? And so that corresponds to the kind of input we've been getting from some of the investors. They're not interested in being famous or being rich. They'd like us to make a profit, thank you. But they're interested in this for the long run and for the public good.
Yeah, I could imagine it's a fascinating, you know, if you were an investor. I mean, everyone's fascinated. It's almost science fiction like, you know, and I think, imagine the individuals you're talking about, you know, are probably family officers or whatever, entrepreneurs that are successful or however it be, you know, like really invested in this personally for whatever reason. I know my dad's 91. He has dementia. You know, what would it be like if it was different, if he was still with us for the next few years without that? I don't know. I mean, I could see it'd be interesting. Like, you know, first of all, like, you know, then again, you know, we've talked a lot, but like, what is it that's causing him to have this? That's a whole nother subject. But this is something that is got a lot of people impacted. Everyone is impacted by this, by a loved one or so anyway.
Yeah, I gave a talk a decade ago with, I think there were 1,000 people in the audience. And rather than asking how many people have friends, relatives, patients, neighbors with Alzheimer's, and said, how many of you don't? There's one hand went up as an 18-year-old kid in the audience, because all of us have somebody we know. You know, I have a friend across the road with Parkinson's. So we all have people who have these age-related neurodegenerative diseases, Alzheimer's or otherwise. This is not a rare disease.
So I feel like this is more of a moonshot. We talk about moonshots. Could a moonshot effort? I know you're trying to, the people that are involved are under the radar, but teams like the only way to really, and then again, it's probably already been done. There's moonshots of this. There's that landscape of the garage, the 2,500 companies that are didn't make it through the desert, but what do you think could be done to help the awareness or the acceleration of leading you where you need to be, to make this a reality?
It is not a matter of money. It's not a matter of hours. It's not a matter of educational expertise. The classic analogy might be the original Indiana Jones movie, where they're trying to find the Ark of the Covenant or something out in the desert. And Indiana Jones and Sala suddenly realize that all the diggers are, quote, digging in the wrong place. And those people who are digging, it doesn't matter how many diggers you've got. It doesn't matter how big your excavator was. It doesn't matter much money you put in. The question is, are you digging in the right place? And we are not digging in the right place when it comes to age-related diseases. So it is not really overall a matter of NIH budget or NIA budget or FDA budget or number of VCs or the money. The question is, where are you putting the money? And if you keep putting it in the wrong place, you still don't get the right answer. It just doesn't make a difference.
So where does that money, where do we need to be?
Well, that's an easy question to ask and an impossible one to answer, because, of course, everybody thinks you should be digging in a different place. And the only way to prove that somebody's right is to come out the other end and say, see, I told you so. It looked obvious in retrospect because here's the right place to dig. But it's not obvious to the NIH, the NIA, the Alzheimer's Association, any number of, the venture capitalists. It's never easy in prospect. In retrospect, seems pretty clear to me. In prospect, people disagree. And that's appropriate. We think we understand how all these diseases work. And it's, the model we've got is consistent with everything we know about upstream risk factors, downstream biomarkers. It's consistent with all the clinical data, all the lab data. Doesn't prove it's right. It just proves it's consistent. And it's, in that sense, a better model. But whether it proves accurate and able to prevent and reverse Alzheimer's disease depends on the actual data.
So where are we on a landscape globally? Any other countries, any interests that you're seeing, positive outcomes that are hopeful that you're seeing across the landscape?
The people who are interested in the same sort of model that we have are out there. Whether you're looking at Korea or the UK or Australia, there are people out there who, Spain comes to mind, Italy comes to mind, Denmark. They're all out there. But again, the way we're looking at aging is not consistent with people's assumptions. As I say, most people assume it's entropic. It's entropy. It's wear and tear. What do you expect? And it's not that simple. And so it takes a different mindset. Sometimes the analogy I use is assume you have a huge building in a major city in the world. You have a major city, huge building. You have a big firm. Say it's a law firm. And you have a beautiful set of offices, but you're spending $1 million a year cleaning it. And you think, I'm going to save money. So you cut back to $500,000. And the place begins to look a little seedy. And the clients begin to complain. Well, the issue is not the brand of window cleaner you use or what kind of a vacuum cleaner you use. The point is you're only cleaning it now once every 3 days rather than once a night. And so it begins to get dirty. It's not how much dirt you have. It's a matter of the fact you're not maintaining it. It's not entropy, it's maintenance. But that sort of model, people don't tend to see. They think of that just in terms of entropy. Example, there was a conference I led in San Francisco on age-related diseases last year. And we had about half a dozen, a little more, speakers get up and said, all aging is related to mitochondrial dysfunction. Well, mitochondria do show dysfunction. We've known that clearly for more than 2 decades. But the question is, if that's true, what caused the mitochondrial dysfunction? We had another set of speakers who got up and said, all aging is related to immune dysfunction. To which my question would be, okay, but what caused the immune dysfunction? People tend to assume that immune dysfunction, mitochondrial dysfunction, DNA repair problems, you name it, just happen. And everything follows from that without asking, why did that happen in the first place? They don't look upstream. They start someplace like mitochondria and move downstream without ever asking where to come from. So that's a generic problem we see as human beings. We focus on the biomarkers rather than the cause of things. I see it in medicine day to day. I see it in the way we deal with cleaning the dishes day to day. It's sort of the way we think. We don't think from a systems perspective. We tend to think on the narrow perspective. A friend of mine used to work for Airbus, and he said they have the same systems perspective in what's going wrong. He said if a fan blade fails in this Rolls-Royce jet engine, he doesn't ask what's wrong with that fan blade, that one particular fan blade in that one place in that engine. He asks, why did the fan blades generally fail in that kind of an engine at that RPM, at that temperature, at 35,000 feet in a major Airbus airplane going along? Why did it fail in context as a gestalt in a system, not just an individual biomarker? And that's not the way we tend to, as human beings, look at aging. We look at aging as, the 11 biomarkers, the 12 hallmarks, the 16. No, that's again, thinking it's like describing COVID as a set of symptoms. COVID is not dyspnea, cough, aches and pains, fever, high white count. No, COVID is a viral infection. It's a systemic problem. It is a process, not just a set of systems, signs and symptoms as a clinical outcome. And if we're just treating signs and symptoms, we miss a bet. But that's common. Thinking more broadly is rare. And that's the kind of thing that I begin to see happening in the world as people realize that treating signs and symptoms of aging just is not effective.
Mm-hmm. Well, it seems like that's how we do it in our sick care model. It seems like we really do not want to get at root cause. There's so much research already on metabolic health, so we're just continuing to spend a ton of money on our healthcare system, and it's working very ineffectively.
I'll give you a little crazy example. Back in the early 80s, we find people diabetics with diabetic ketoacidosis, a high acid level in the blood, obviously very sick. And the temptation was to treat the acid. You'd give them sodium bicarb, and they got sicker. You adjusted the pH of the blood, fine, but they got sicker because we were treating an outcome, not the process. We weren't treating the system, we were treating an outcome. And again, that just doesn't work. It's just poor thinking. So yes, you're right, we do that.
Well, what would you like to uncover today or share more of? I mean, you've been working at this your whole life. I'd love to know if you didn't go where you went on this path, where you'd be. I still think some sort of astrophysicist. I mean, you're like really splitting atoms with what you're doing. But where would you like to go today on this conversation? We still have a good bit of time.
Well, I didn't mean to end up in any of this. I had a position in early Buddhist philosophy. I was going to go learn languages. And then I got talked into taking GREs, and I couldn't figure out where the numerator was. I thought I got the denominator. It turned out that I gotten perfect scores in all my GREs. And so my advisor talked me into going to grad school. So I borrowed 3 applications, drove a moving truck to California, hitchhiked up the coast, got into Stanford, and enjoyed myself thoroughly. And then I didn't mean to get into medicine, but I ran into somebody one day who asked if I thought about going to medical school. And I said, why? Who are you? He said, actually, I'm dean of admissions. And then they said, would you like to be a professor in the professor track at Stanford or a lecturer? I said, well, I'd love to be in the professor track. Why would I want to be a lecturer? And they said, professors don't get free tuition. Lecturers do. I said, I'm a lecturer. So they paid for my MD, which is awfully nice. I keep stumbling into these things by mistake. It's sort of, I call it the reverse paranoia theory of the universe, when good things happen for no apparent reason.
I love that, the reverse paranoia of the universe effect, or whatever. That's a book of itself. That's a title right now. We should anyway. But I really am glad you came on. I really try to have super interesting people, and you fit that category to a T. And I think of you, the little bit, I never met him, Richard Feynman, but you are the Richard Feynman of aging. And I would hope that your fruits of your labor are realized in your lifetime.
As they would say in Arabic, inshallah. Okay, let's hope. Or in Italian, Deo volante. Let's see.
So I don't want to take too much of your time. We still have time. But I want to try to get here as deep as we can on this subject, or digress to something else that's important. And we got about 10 more minutes left or so. So where should we go? Well,
let me look a little more closely then at aging for the fun of it. I tend to think of things as upstream and downstream. There's that old apocryphal story about the person standing by the river and somebody comes down drowning in the river and they save them. Another person comes down drowning in the river and they save them. After a while, you realize that it's good to haul them out, but who's throwing all these people in the river upstream? And that's sort of, in a sense, the model here. What I see is, let's take the example of Alzheimer's disease. I know that if you have two ApoE4 alleles, you have a higher risk. But why? I know that if you have a history of head injuries, you have a higher risk. But why? We can come up with all sorts of other things. A history of for example, encephalitides, that is CNS infections, higher risk. But why? And there are all these upstream risk factors. Some of them are microbiome issues and dietary issues, exercise, history of cancer, exposure to radiation. I mean, just go on and on about things that adjust your risks up or down. But why? And we know all of these things downstream, all these biomarkers. But why? How do they go from one to the other? And I think what you're looking at again is upstream risk factors that either affect cell aging, the rate at which your cells age, or they affect other things that are related to cell aging. For example, we know that if you have two ApoE4 alleles, you tend to make stickier beta amyloid proteins. And it turns out the rate at which you recycle those proteins goes down with age. So if they're stickier, if I'm, say, 40 years old and I have two ApoE2 alleles, I have very low risk because I don't make sticky proteins. Even though my cells will begin to slow down, not a problem. But if I have two ApoE4 alleles, stickier proteins, so at age 40, I'm beginning to run into problems. So it all plays out on this stage of, are my cells aging and are they slowing down the rate at which they recycle proteins and other molecules? And it all has an outcome. Another example would be mitochondrial aging. We know that the rate at which you turn over aerobic enzymes goes down with age. So you begin to get more free radicals. Free radicals go up with age, and free radical damage goes up with age. We know that if you, as your mitochondria get older, again, because of changes back in the nucleus, the rate at which your membranes leak goes up. So you got leakier membranes, more free radicals, more free radical damage. The rate at which you scavenge your superoxide dismutase, for example, and catalase, the rate at which they scavenge free radicals goes down with age. Because again, you're turning over these molecules more slowly. So, the rate at which your cells turn over aerobic enzymes, the rate at which they turn over lipid membrane molecules, the rate at which they turn over scavenger molecules, the rate at which they replace damaged molecules all go down. So exponentially, you see this increase in essentially mitochondrial dysfunction and consequent damage. But it's not because of the mitochondria, it's because of the way the cell is aging and it's dealing with the mitochondria. So, wherever I look, whether I'm looking again at DNA repair or mitochondrial dysfunction or immune function, glycation, wherever I'm looking, what I'm seeing is this slower rate of turnover. Back to that analogy about what happens when you don't clean your office building as often. You clean it once a week, once a month, it looks like hell. Clean it once a day, it looks sparkling. It's the maintenance. The amount of dirt's the same, the amount of entropy is the same, the wear and tear may be equivalent, but the question is, are you repairing it? And that works very well in, for example, the germ cell lineage, which is why every cell in your body theoretically is 3 billion years old, 3.5 billion years old, because it goes back, and the germ cell lineage has maintained itself more or less flawlessly over that time. A lot of exceptions to that, but you're essentially several billion years old, but your cells haven't shown significant aging until an inflection point a couple of decades ago, and the same for your mitochondria. So it's, again, from my perspective, the problem we have with aging is we get too myopic. We tend to focus on human beings, dogs, cats, cattle, birds, without looking at other organisms, and without looking at things like the germ cell lineage. And it blinds us. It prevents us from making progress. But I think we're going to get there finally.
So you just made me think of octopuses and sharks and stuff like that, and frogs. I mean, learning from other organisms too? Is that a?
Oh, yes. Here's one question. Why do mice age faster than we do? They have a lifespan that's perhaps 40 times shorter than mine. On the other hand, and back to telomeres in this regard, they have telomeres that may easily be 10 times longer than mine. And as it turns out, it's not a matter of the length of telomeres. It's not just that. It's a question also of how fast you lose telomeres. More importantly, how fast that changes gene expression. So these things get wildly complicated. And And one of the problems that we've seen with regard to the issue of telomeres and aging is just that, which people confuse length of telomeres with aging. No, it's the change in length in telomeres. The other problem that we've seen that is universal in the literature is people measure the telomeres in peripheral blood cells. It's pretty easy for me to talk you or other patients into giving a blood sample. It's pretty hard to get them to talking to giving a brain biopsy or a heart biopsy. It's no, thank you. And so what happens is people measure peripheral leukocytes, that is peripheral white cells, which have almost nothing to do with most age-related diseases. And then they get this wishy-washy data and say, well, maybe it doesn't have anything to do with cell aging. If I'm measuring your peripheral white cells, what has that got to do with my knee joint, the chondrocytes in my knee, and osteoarthritis? What does that have to do with the coronary artery cells, the vascular endothelial cells? What does that have to do with the microglia in my brain? Not much. So you see all of these problems occurring in terms of people's inadequate conceptualization about how aging works and what to do and how to test it. Another example is that people tend to talk about cell aging, and sometimes by that they mean terminal cell senescence, that is replicative senescence. The telomere is very short and the cell doesn't divide mostly. But you could also be talking about the whole lifespan of changes. I mean, your cells have been aging now for decades. And they didn't just cell aging is not just a terminal event, it's the lifelong changes that occur in gene expression. But in the literature, if I say cell aging or cell senescence, which am I talking about? So people talk about apples and oranges in these conversations. And another one is people confuse the issue of telomerase and cancer. And they think of it as a sort of a yes-no phenomena. If you express telomerase, you increase the rate of cancer. Well, not really. It depends. It's more complicated than that, like most things. And in fact, telomerase can be protective against cancer. It depends on the context, the cell involved, how short the telomeres, how much damage there's been. It's complicated. But that's been a huge problem in our being able to make progress, which is people have simple-minded way of looking at things. Telomerase is bad, telomerase is good. Telomeres are good, telomeres are bad. Long ones are good, long ones are bad. Measuring white cells are good, but no, it's complicated. And to think otherwise is naive, and it prevents you from making any progress.
So it means I can't just drink a glass of red wine a night and think I'm going to do better, huh?
Oh, I think you should definitely do that. And not because it'll affect your telomeres or cell aging, but because you probably feel better if you do.
So what are some things?
I have to point out alcohol is probably bad for you in the long run. That doesn't prevent me from having a glass of wine, I confess. But
yeah. So I know this is kind of a side note, but what are some things people can do? And you can just say, no, I don't want to get into that. But just lifestyle, what would you say are pretty gold standard things that people could do? Now we're getting into, sorry.
No, everything that people can do are things that everyone knows about. And your grandmother told you and your doctor told you, and you didn't pay attention to either one, and your doctor costs more. But these are not new and they're not sexy. Let's see. One of the best ways I know of extending your healthy lifespan is to fasten your seatbelt. Yeah, all right. And then we can move on to things that really people think about. For example, lowering stress, good diet, exercise, improve your microbiome. You can go on and on with this. Avoid sun damage to your skin. Avoid radiation. Yes, all of which is fine. They don't prevent aging. They don't stop aging. They may slow aging and postpone age-related diseases. I'm perfectly happy with you. You should do all those things. But that's not where we're going. We're talking about actually reversing the process.
Yeah, I love that. But what about, am I fooling myself with this ketogenic diet that I've been on for the last 11 days?
A lot of times I've taught courses on the biology of aging. And one of the sections invariably is gastrointestinal aging. And I start, because I'm going to talk about diet, with this lovely little picture of a fuzzy creature. And I say, anybody who can identify this creature right now, raise your hand, will get 5 points in your final grade. No taker. Okay. That is Lemmus lemmus. That's the Norwegian lemming. And, the idea is they all go off the edge of a cliff, which they don't. But that's the way we treat diets. There's the fad diet of the day, last year, this year, Paleolithic, ketogenic, non-ketogenic, high carb, low carb, high protein, low. And we act like lemmings on this. And I suspect, again, all of us in our hearts know that the diet, as somebody once said, shop on the outside of the grocery store, not the inside. That is, shop around the dairy, the fresh produce, the meat, and skip all the things and packages in the center that cost more. Or as somebody else said, never eat anything your grandmother wouldn't have been able to pronounce.
Mhm.
And we all know that, a reasonable healthy diet, vegetables. There's nothing against meat. There are times when people have recommended nothing but meat diets, and other times when they've recommended never have meat in your diet. These come and go, but
Mhm.
no, in all things moderation. I think all of us know sort of what a reasonable, sensible diet is. I don't follow it. You don't follow it. None of us do, because every now and then we'd like a chocolate mousse
Or Taco Bell,
or a
right? I mean,
Taco Bell,
I mean, I
or,
hate to say it, even
or
if you love good, authentic Mexican food, there's nothing like this weird thing called Taco Bell. I mean, when
and tell me McDonald's fries are horrible and to eat. Oh, they may be horrible to eat, but they're tasty. Okay, so it is.
yeah.
Potato chips.
Well, tell
So
me,
no,
like, if this
so
was,
I'm in favor of
sorry,
your ketogenic diet or any other diet. I hate to think of it as a religion. That's all.
yeah, no, I get you, but what the only thing good about these religions is it's unlike the dogmas. A lot of times people switch out, so that's a good thing. Like, it's not necessarily cult, uh, per se, like, because after 6 months, they might just join the other cult. So that's
Change
at least
change
good, right?
religion. Yes.
Yeah. So, what I am curious about, do you ever see, like, I think, would this be like as a tablet, blood draw? Like, how would the modality you would see most likely? How would we see this application for?
Initially, in the human trials, it's going to be an injectable, and there's some question in our minds about how we'll administer it. But the default is a lumbar puncture when we're dealing with Alzheimer's disease. Actually, intrathecal, but it could be IV, it could be intranasal, it could be oral, it could be a pill. Ultimately, and what we're dealing with is not something you take once and get rid of age-related diseases. You'll need to reset it. So think of it as this. Think of it as, if we can do this, what we'll do is we'll take your cell aging and take it from, say, age 70 back to age 40. But that means 30 years from now, you'll be 70 again. So you reset the clock, but the clock is still running, still needs to be reset. So really what I'm saying is, every few years, whether it's 5 years or 10 years or whatever, depending on the person, you'll need to be treated again, which brings up some interesting issues with regard to immunogenicity of viral vectors and all sorts of questions. There's a lot we're just not sure of yet. But yeah, we're looking at recurrent therapy, not a single therapy. But
And
we're
is
not
it?
looking at daily therapy either. We're looking at every couple of years, as it were.
That's really cool. And do you see AI? I mean, AI is so buzzy, but wouldn't that be helping kind of getting at the like all the different, when you talk about this multifaceted universe, it's almost so many variables. Would you be using AI to kind of delve deeper in all these factors?
Yes and no. I mean, the problem with AI, again, is asking the wrong questions. If I have an enormous bulk of data, AI may be able to help sort that out for me in a way I couldn't otherwise. Example, we used to talk about determining, if I have a young child in the emergency department, do they need to be hospitalized or not? Are they sick or not? And you found that people who were naive physicians and nurses couldn't tell. And you get the grizzled old pediatrician look and say, that child's sick, admit them, and that child's healthy. They'd be pretty much right. And then we tried to come up with ground rules for this. Measure the temperature, how they make eye contact, do they eat, all these things, and we'd score them. And that got pretty good, although we had a hard time 20 years ago making that any better than the grizzled old pediatrician who knew that was sick, that was healthy. Now, AI is doing a better job at that kind of thing, determining who in the ICU, for example, is going to crash and who isn't. We're getting better and better because AI is good at looking at all those details, making all those correlations, putting all the thing together and saying, that one is in trouble. Okay. So AI is useful for that. Where AI is not useful is making intuitive leaps. So let me take you back about 200 years to the death of George Washington. He's got two physicians, and he's essentially dying of sepsis. I mean, we don't know quite what it was. It was probably a strep sepsis. And they were using enemas and bloodletting. Those are the two major things they used to try to treat George Washington. And about 2 days later, he's dead. Now, say we had taken back AI to them, and for that matter, gene-wide surveys, precision medicine, I mean, all sorts of quantum computers, I don't care. Take it all back and given it to those physicians, what they would have asked is the wrong question because they knew nothing about microbes. And we would now have the world's best possible enemas and bloodletting. See,
Yeah, I
and
love that. So basically what you're saying essentially is AI is great for what we know to make it quicker and better and more effective. But if we don't know, it ain't gonna.
well, back to the example of which person in the ICU is going to crash or which baby is, quote, sick. We sort of know there's a difference, but we don't have to tell all the time. AI is getting to be a little better than the really experienced physician is at this. So we know what the right question is, which one's going to crash? And AI can answer that question. But when it gets to the question of sort of what causes aging, AI is not very good at making those sort of intuitive leaps and understanding it. They're good at putting together data. So example, let's say I said to you, I've got 43 different compounds that may have an effect on Alzheimer's. Survey all the world's literature, all the data, and tell us which one of those 41 small molecular compounds is most effective for Alzheimer's. Bingo, here are the 3 that are best. Okay. But you've already assumed it's a small molecular compound that's what you want. You've already assumed that what you're going to be doing is intervening, for example, in beta amyloid or neurofibrillary, and that's the wrong assumption. It's like assuming that aging is just entropy. Yeah, it's got a lot to do with entropy, but it's not just entropy. So the problem isn't that AI's got enormous potential, super potential, but it can't kind of take that intuitive leap beyond what human beings do yet. It probably will at some point, but we're not quite there yet, Michael.
Yeah. Well, this has been a really amazing talk. I have learned so much today. I've been energized. I have not even been able to finish my cup of tea, which says a lot through this conversation. And I know our audience, if they hear this and listen, though they don't, only but so much, right? But if they do hold fast to this whole conversation, I imagine they would be very much, bemiffed or intrigued beyond belief or disbelief or whatever you want to say with aging and what it is and what it is not. And really, I think when I hear this and when talking with you, I want to know more. To me, it's like you can't but be fascinated by what you're doing. So I know you have a book out. Is there anything else you'd like to share with our audience, how to find you? I know you're pretty low key. You might be hiding in your tea house back somewhere, but tell us a little bit how you'd like to end here today. Okay.
By pointing out that, not only is aging far more complicated than most people think it is, and I think that several of us have got a grasp of that, but it's far more complicated than we think it is too. There is, let's assume something that not at all in evidence. Let's assume that I and a couple of people who are involved in this know more than 99% of everybody else involved in it. We still know less than 1,000th of what there is out there, probably a lot less. We're taking baby steps in this. This is just the beginning of understanding of some of this. And I think we've made some progress conceptually and in terms of the data as well. But we're nowhere near, going back, say, 200 years, and our earliest knowledge of microbial disease is not the same as what we know now. The same is true of aging and age-related diseases. I think we're about on the verge of making a huge forward step. It is not the last step.
Nice. Well, thank you so much for coming on today, Michael.
Con mucho gusto.
Mucho gusto. De nada.
Igualmente, Miguel.
Yeah. Miguelito. Yeah. All right. Until next time on Planetary Health First, Mars Next. I hope you've enjoyed the journey with us, friends. Until next time.
Thank you, Michael.